All right, this is a lesson on section 1.3, intersection and union of two sets. So you want to have your formula sheet handy because we'll be referring to a couple of things on there. And so we're starting off with two definitions. First off, intersection, which is a set of elements common to A and B. So here we want to associate intersection with the word and. And our symbol for the intersection is over here. The intersection of A and B is that upside down U. So if I draw a Venn diagram that would show the intersection, here's set A, here's set B, and their intersection is right here. And the other idea over here is that of the union. And here we want to associate union with the word or. So elements that are in set A or set B. So if I draw the same Venn diagram with set A here and set B there, and I point out again that the union symbol is this regular U, so A in union with B means the union of A and B, and the way that we would show the elements would be everything that's in A or B. So again, just to reiterate, A in intersection with B means A and B, this section. Elements that are in both A and B. Whereas over here, A in union with B means anything in A or B. So that's everything in those sets. All right. So now the idea of A minus B over here, that slash means A minus B. And we've got a couple of different scenarios where we're looking at A minus B, 3 of them. And the first one over here, if B is a subset of A. So remember that that means we would have set A and B is within set A. B is the one that is a subset of A. Remember again that sideways U right here means a subset of. So the way I would read this out would be A minus B if B is a subset of A. And so that would be all of the items in A minus B. It would be everything out here. And next, in the second case, we have A minus B. If A is not a subset of B, and B is not a subset of A. So here what I'm trying to show is that these two sets are disjoint. So disjoint sets would look like set A and set B. So A minus B would just be everything in A. I start with what I have in A, that's where it's starting me off at, A, take away B, but there's nothing overlapping here, so it's just set A. And then here, in the third case, A minus B, if A and B have an intersection. So this means that there are some common elements. So again, here's set A, here is set B, and A minus B would be everything in here. I start with A, which would be all of this, and I take away B, which means I take away that intersection there. So A minus B, if I have an intersection, that's what this is saying, would be just these elements in that part of just A. So now, again, we're going to look at some sets that are either disjoint, looking at the idea of union here and intersection. And then sets that are not disjoint, again, the same two ideas. Union here, remember the symbol again for union, the U, that's an easy one to remember. And for intersection, the upside down U, like that. So if I have a disjoint set, here's A, here's B. And the union of A and B means anything in A or B. So again, I want to associate the idea of union with the word or. And the symbol, of course, being that U. So that's anything in A or B. And now the other idea, the intersection of A and B. So this is A and B. And if I look at a disjoint set, the question is how many elements are in A as well as or and B? And the answer is none. So there's no overlap. The intersection of A and B is the empty set. Remember, this symbol means empty set, same as the set of brackets with nothing in them. And here are number of elements. The number of elements in the union of A and B, that's our first diagram, that was this one, is the number of elements in A plus the number of elements in B. So I would just add them up. If I had, say, 3 numbers in this set up here, this one, and 2 in here, then the number of elements in the union would be 5, that 3 plus 2. And then lastly, on this side, the number of elements in the intersection of A and B is none. Because we don't have an intersection, it's the empty set. All right, going back over to the other side where our sets are not disjoint, where we have an intersection. So there's set A and there's set B again. And I haven't really put any numbers in my sets or any elements in there, but we're just going to show by shading, as I did over on this side, to illustrate the point. So A in union with B means anything in A or B. So anything in A or B is everything that I have there. And now the intersection in the second box here, again, we're going to show A and B. Elements that are in A and also in B, would be right here. That's the intersection, that overlap. And so the number of elements in A in union with B is equal to the number of elements in A plus the number of elements in B. And so if we return our attention up to this diagram here, I'll just show that again. Open that. There we are. Set A and set B. I'm adding up everything in A, and now I'm also adding everything in B, and you can see hopefully what happened there. I added this section twice. So down here, when I add everything in A and everything in B, I also have to subtract the intersection of A and B because I added it twice. And this is what we call the principle of inclusion and exclusion, and that's on your formula sheet as well. The principle of inclusion and exclusion. All right, so got some Venn diagrams here showing just set A, just set B. Over here, the complement of A. Remember that the apostrophe means the complement of A let's ignore those. I feel like there might be an error there. I'll come back to that later and move on to this example, which has a universal set. Looks like 2, 3, 4, we're missing 5. All right, set A are multiples of 3. And it looks like set B are multiples of 2 up to 14. So if we're going to create a Venn diagram, what we want to do is look at what's in the universal set. That's all those elements have to go into this box. And we have set A and set B. And what we want to look for is any overlap. And so what we notice is that they both have 6, and it looks like they both have 12. And that would be because 6 and 12 are multiples of both 3 and 2. So I'm going to draw set A over here. Set B over there. And in A, I'm going to write 3. 6 I'm going to write in here because it's also in set B. 9, 12 would go in there as well, and 15 would be just in A. And then over here, I'd have 2, 4, 6 is already in there, 8, 10, 12, and the last one is 14. So there's my two sets. Notice that the number 7 is over here. It's neither in A nor B, so I'm going to put that item just over here in set U, right, in the box that is the universal set, but it's neither in A nor B, so it's out here on its own. And now we're asked in part B to determine the number of elements in set A. So I would say the number of elements in set A, that's the way I write that, is equal to, and then I would just add them up, 3, 6, 9, 12, and 15. So that's 5 things, 5 elements. Looking at in set A but not set B, so that's our subtraction, that slash. In set A minus B is, if I look over here, this is set A, again, just draw another circle around that, minus this. So that's only these items here. So that's only those 3 elements in set A. So this is 3. And the number of elements in set B. Number of elements in set B is 1, 2, 3, 4, 5, 6, 7. So I have 7 elements in that set. Oops. Next, in set B but not set A. Just go back here. In set B, maybe I'll just write those questions down here so we can see what we're doing. So in set B but not set A. So the notation for that is very similar to this one, except it's the opposite order. So the number in B minus A. And so that's going to be just this part here. 1, 2, 3, 4, 5 items there. Next, part 5 asks for in set A and in set B. So in set A and set B. So the word and, remember, that refers to the intersection. Which elements are in set A as well as in set B? So the notation for this is the number of elements in A and, which means the intersection with B. And so that's this section here in the middle. And there are 2. It's the 6 and the 12. Number 6 says, let's extend this, there we go, set, in set A or set B. So again, that or right here is a hint for us, and that tells us we're talking about the union. Oops. Union. So the number of elements in union, in A in union with B. So we're going to just go back so I can see my diagram. How many elements are in A or B? And so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's everything in either of those sets. So that's our union. Number 7 is the number of elements in A apostrophe. Remember, this means the complement of A. So if I look back at that diagram, it means I start by covering up all of A. So if I covered this all up, what do I have in the complement of A? Well, I have these 5 items here, and I have this 7. So back. The number of items or elements in the complement of A would be those 5 that were in just B plus the 7, so that makes a total of 6 there. Okay, let's move on. There's the questions. List the factors of 24 and the factors of 30. So these I like to list in pairs. So 1 times 24, and so on, and down here 1 times 30. So this might be a good point to pause the video and you guys finish this list here and here, and then put your items into this Venn diagram down here. Okay, so our factors should be 1, 2, 3, 4, 6, 8, and 12, and 24. And then down here, 1, 2, 3, 5, 6, 10, and 15. So again, in pairs 1 and 30, 2 times 15, 3 times 10, and 5 times 6 are the factors of 30. And now if I fill in the diagram, they share 1, they share 2, they share 3, as well as 6. And then on just the 30 side, I have 5, 10, 15, and 30. And just the 24 side, I've got 4, I've got 8, 12, and 24. So let's call this A and this B. So there's A, set A, and this is set B then. So these questions aren't in your notes if you have them printed off, but I'd like you to give them a try. So I'll write them out, and then maybe you can pause and try and answer them. So I'd like to know, what is the number of elements in A in union with B? I'll call that question 1. Question 2, the number of elements in A in intersection with B. Number 3, the number of elements in the complement of A. Number 4 will be the number of elements in the complement of B. And let's leave it at that. All right, so the number of elements in A in union with B means I add up all of them. The union means everything. So over here I've got 1, 2, 3, 4 elements in here. Just put a little 4 with a circle on it. Remember, that's not an element in there, or rather it is, there's a 4 here, but I'm just showing that's the number in that section. 1, 2, 3, 4 in the intersection, and 4 over here as well. So the number of elements in A in union with B should be 12. Here, the number of elements of the intersection of A and B, well, that's this section right here in the center. So that is 4. In the complement of A, that would be just, so again, you start with A, and I would cover that up with my finger and not see those elements, and I would only see these guys here, the 5, 10, 15, and 30. So that's 4 elements in the complement of A, those 4. Oops. And similarly down here in the complement of B, I would put my finger right over this and cover that up. So I'm only looking at now this section over here, and that's 4 items as well. Also in the complement of B would be any numbers that we would have written over here. That would be in set U, the universal set, but not in sets A or B. All right, that's that.